Check one, two, test, check. Hello. check.
I request all of you to assemble in the auditorium. ಸರ್ ಅಜಿತ್ ಸರ್ ಎಲ್ಲ ಬಂದಿದ್ದಾರಾ
ಸ್ಪೀಕರ್ಸ್ ಏನು ಚೇಂಜ್ ಆಗಿದೆಲ್ಲ ನಾನು ಕೊಟ್ಟೆ ಅದು ಅಲ್ಲ
ಸೇಮ್ ನೋಡಿ ಒಂದ್ಸರಿ ಚೆಕ್ ಮಾಡಿ ಜಸ್ಟ್ ಹಂಗೆ ಕಮ್ಮಿ
ಎಷ್ಟು ಜನ 4 ಜನ ಇರೋದು
ಸ್ಪೀಕರ್ಸ್
ಸ್ಪೀಕರ್ ಮನೆ ಯಾರಿರೋದು
ನೀವು ಇರ್ಬೇಕು ಸರ್ ಚೇರ್ಮನ್ ವೇಣುಗೋಪಾಲ್ ಒಬ್ರು, ಆಮೇಲೆ ವಾಯಸ್ ರೆಡ್ಡಿ ಬಂದರು.
Yes. A very good morning, ladies and gentlemen, and a warm welcome to our respective guests, distinguished dignitaries, esteemed speakers, faculty members, delegates, participants, and all our guests. We are delighted to have you with us as we begin day 2, held by Mine Safety Association Karnataka in association with Mines Engineer Association of India, organizing National Mining Conclave 2026 and Soumya.
I'm Megha, geologist from KSMCL.
Yesterday's sessions were filled with insights, meaningful interactions, and valuable learning experience. We sincerely thank you all our speakers, guests, and participants for making the first day a great success.
Today, we begin this event with an exciting lineup of sessions, presentations, and discussions that we promise to be equally engaging and enriching. Without further delay, let us begin this program. To commence the program, I would like to invite you all once again. Next. Now we will begin technical session 4, topic on smart mining, advancing smart and intelligent mining practices. Now I invite Chairman Y.S. Reddy and Dr. T.N. Venugopal on the stage.
Please give a big round of applause. Please give a big round of applause.
Handing over the stage also.
And thank you, and we wish you a grateful day ahead.
Good morning. Once again, welcome all of you to this fourth technical session. We have four speakers. I request all the four speakers, Mr. John D. Shrikant Vairagi, Naresh Patel, and Deepak Sharma, Sanjeev Kumar Tiwari. I request all the speakers to occupy their seats. other two speakers. Yeah. I think organizers are given time of 20 minutes for each speaker. I request the speakers to stick on to the timings allotted. And first speaker is Mr. Johnson. Yeah. He will speak on carbon phase transition rock breaking technique. Briefly, I will introduce Mr. Johnson. Mr. Johnson is the Assistant General Manager Mines at Kallakudi Limestone Mines, Dalmia Bharat Cement, Tiruchirappalli, with over 25 years of experience in mining and cement industries. He is a BA graduate from Nagpur University, 2001 batch, and began his career with VM Selgaonkar and Brothers Goa before gaining over 12 years of international experience in the Gulf on greenfield cement plant and mining projects. He later worked with Ultratech Cement and joined Dalmia Bharat Cement in 2022. He has led digital transformation initiatives, SAP implementation, and innovative mining projects focused on improving safety, productivity, sustainability, and operational experience. Now, over to Mr. John.
Good morning to all respected dignitaries on and off the dais, members from Safety Association, MEAI members, and distinguished guests and fellow mining professionals. On behalf of Dalmia Bharat Cement, I sincerely thank to the organizers who given opportunities for this present innovative rock breaking technology at this CONCLAVE 2026. We are all familiar with conventional and non-conventional method of working. That is, conventional breaking have lot of some safety concerns about ground vibration, fly rocks, excessive noise, and air dust pollution. So we are proud to introduce the India first trial in mining of carbon phase transition in rock breaking technique, in short, CPT-BT, a technology brought to India from overseas. This innovative method utilizes rapid phase of liquid carbon dioxide into gas to generate high pressure of energy to make the rock fracturing without use of conventional explosives. So this technique offers a lot of key advantages, including enhanced safety, reduced environmental impact, precise and controlled rock fracturing. This can be used in sensitive areas like construction sites, tunnels, mines near highways, railways, wherever the blasting is difficult and not permissible. So we have conducted scientific study in Kallakudi limestone mines. Why we choose Kallakudi limestone mines? Because this mines is situated near the National Highway 81. And there are a lot of villages surrounding the mines. So along with our SIMFER team, we have done this scientific study in Kallakudi mines. Almost we have conducted 10 trials, series of 10 trials. They have arrived on 23rd May to 28th May. So during this study, we have conducted with different configuration parameters, including drilling. Single row pattern, double row pattern, even the holes ranging from 1 hole to 20 holes. And the spacing was ranging from 1 meter to 1.9 meter, and the burden ranging from 0.7 to 1.1 meter. Even the CO2 filled in each tube ranges from 4 kg to 6 kg. So this principle will be later explained by my accompanying Mr. Raghuram. So the ground vibration, normally when we do conventional blasting, we measure 1 or 2 ground vibration with the monitor. But our Simford team, they have installed around 7 monitoring stations, all the directions, including top and bottom of the face. So the peak particle velocity was at 150 meter is 0.783 mm per second. For the distance 25 meter to 50 meter, the PPV is 5 mm per second, less than that only, which is safe limit. And the air overpressure during the trials was maximum 133.2 decimals at a distance of 10 meter from the trial phase. There was not much fly rock observed, but one trial there was a fly rock because we have conducted the worst scenarios in all the trials. So displacement from the trial phase is 10 to 20 meter only. The rock was which moved from the phase is maximum 20 meter only. So we have conducted the CO2 concentration analysis also. After the trial, 8 to 20 minutes, the trial range from was 0.01% to 0.42% during the trials. There was no oxygen deficiency in all along the phases. So based on this observation, monitoring data, the scientific analysis carried out by Simfer is very safe and can be implemented in all the mines where the sensitive areas. So these are some photographs during the trial. So you can see the size of the boulders. It was maximum 1 meter. It can be easily broken by secondary breaking. A small video clip I am playing, 2 minutes.
India's mining sector is transitioning toward a safer, more sustainable future. For the first time in the nation's history, the carbon phase transition rock breaking technique, CPTBT, greetings from Velsen X Rock. India's mining sector is transitioning toward a A comprehensive series of 10 rigorous trials was executed, ensuring operational safety and performance criteria. Conducted at the Kalakudi limestone mines at Delmiapuram, Tamil Nadu, under the evaluation and presence of DGMS and CSIR, Central Institute for Mining and Fuel Research scientists. This milestone initiative was made possible through the strategic collaboration of Dalmia Cements Bharat Limited, DGMS, Central Institute for Mining and Fuel Research, and ARN Earth Movers India Private Limited. As mining boundaries advance, CPTBT stands as the ultimate non-explosive solution to eliminating fly rock and ground vibration risks. Velsen X Rock is proud to spearhead this sustainable leap toward absolute mining safety in the country. Special thanks to Directorate General of Mine Safety, DGMS, CSIR, Central Institute of Mining and Fuel Research, CIMFR, Dalmia Cements, and ARN Earth Movers India Private Limited.
Now I request Mr. Raghuram to take you to the presentation regarding the principles of CPTPT.
Thank you, Mr. Johnson, for setting the context so brilliantly. A very warm good morning to the esteemed dignitaries from DGMS, MSAK, MEAI, and distinguished guests present at this National Mining Conclave. I am Raghuram Ravichandran from Wilson Extrock, the CEO of the firm that brings this technology for the first time to India. It's an honor to address you today, and thank you for the opportunity. I will now take you through the fundamental principles, operational mechanism, safety parameters, and the carbon footprint reduction achieved by the carbon phase transition rock breaking technique. So the very first motto, as most of our seniors say, necessity is the mother of invention. So the necessity here is, if not the mines are near the habitations and they can do through a fulfillment of mining technologies, there is no other option that we can take the logged mineral, which is near to habitations and surrounding areas. So we have very few methods that extract the minerals over these very sensitive regions, like primary rock breaking, which is time consuming and it's not volumetric matching. And you have splitters, which is again time consuming. It does not matches with the volume that the requirement is there. So the basic principle of how the CO2 breaking works is through liquid carbon dioxide. At its heart, the carbon phase transition rock breaking technique revolves around one simple motto: harnessing the power of CO2 phase transition to break the rocks silently and sustainably. First, the liquid carbon dioxide, which is by inherent in its nature at around minus 40 degrees Celsius, is compressed into a high-strength cylindrical steel pipe from a storage cylinder. And the steel pipe is made up of 42 grade chromium, molybdenum, manganese, and other alloys as well. So inside the pipe sits a heating element. The heating element will act as an initiator, which initiates this phase change of liquid carbon dioxide gaseous form, liquid form into the gaseous form. And during this transfer, we have enormous amount of pressure released along with cracking mechanism that we tape to use break the rocks. The liquid CO2 is filled inside the steel pipes at around 130 bar, which is otherwise 13 megapascal, through a reciprocating pump, especially for filling this liquid carbon dioxide. So what happens when this initiator is exposed to some current of around 2000 volts, 10 milliamps? The phase change starts to happen. So within a fraction of a second, the liquid carbon dioxide converts into gaseous state, rupturing the disc which is at the bottom of the steel pipe, venting out through the vent as you can see on the image here. So the factor of safety of the steel pipe is 2.5 times, that it can withstand 7,000 bar, whereas your braking mechanism just requires 3,000 bar. And the process stages involved in CPTPT. As in other process you do likewise for normal blasting, you drill the holes. The drilling hole is around 140 mm and you fill the carbon dioxide into the steel pipes. Usually, as Mr. Johnson already mentioned, each pipe can accommodate around 4 kgs to 7 kgs of liquid CO2. And then transport the pipe to the mining bench or the mining area where you need to have this process started. And you insert the pipes into each of the holes, either in a straight line pattern or a staggered pattern. And then you have to do stemming as you do it in other blasting cultures and connect in the series form. And then we initiate the process for phase transition. These are some of the images that we have got here. The steel pipe, as I mentioned, has a thickness of around 20 mm, and the rupture disc has a thickness of around 10 mm, which is of mild steel. And to your right, you can see the heating pipe that initiates this entire process of phase change from liquid to gaseous form. These are some of the photos that we took during the preparation and execution of this trial. So the preparation shed is where you prepare all the steel pipes and you fill the CO2 into it and repair the pipes in case if it's bent or needs some repairing works. And the entire kit, technical and operational specifications consist of the entire kit, not only the steel pipes and the initiator, but also liquid storage tank, liquid carbon dioxide filling machine, which is a reciprocating pump, a liquid CO2 machine, as I already mentioned, and a table, rock breaking pipes, heating pipes, air compressor and wrench to tighten both the ends of the pipe after everything is inserted and ready for filling. And you also have multimeter initiator and also a pipe straightener where you can straighten the pipe in case during the recovery if the pipe is prone to some damages. And this is with respect to how much is the fuel emission and how much is the production output that you get when compared to primary rock breaking, especially the study that we have taken in Dalmia Cements Bharat Limited, Tamil Nadu. So putting in all the numbers together, we came across 43% of fuel savings, which amounts to, and the reason as to why we have the savings here is through the breakers. The amount of breakers that you use when compared to a primary breaking or a splitter breaking is significantly reduced here because the initial fissures on the rock is already being created through this CPTBT technique. And when compared to CO2, as it's a directly proportional to the machineries involved, so we have 39% of less CO2 when compared to the primary breaking and splitter operations to extract the rock. So which means it also saved 2 tons of CO2 every day for 3,000 tons of rock processed. We have also collaborated with SIMFER under the aegis of DGMS. SIMFER, we have had around 7 scientists visiting Dalmia Cements Bharat Limited, and through rigorous trials and brainstorming sessions we had with them, we had to put the pipes and trials in a very extensive manner in such a way that extreme conditions have been accounted for. So this marks as the India's first scientific study combined with SIMFER under the aegis of DGMS, and we have also awaiting the report from SIMFER as of now. So this transitions as a new mining method as long as we need to have mining done in a very sensitive areas, especially near to habitations and infrastructures. So this technology has already been implemented and trialed, tested in Dalmia Cements Bharat Limited, and it's been found successful there. And also in terms of volume, in terms of safety, and in terms of other parameters that they needed, it was found suitable and safe there. And we are awaiting a report from SIMFER, and after which I take this opportunity, especially to deepest gratitude and respect to Directorate General of Mine Safety. And we are immensely thankful for the DGMS to granting us a trial study for this novel technique for the first time in the country to be done along in association with Dalmia Cements Bharat Limited. And I also wish to thank Dalmia Cements for providing us a platform at their mines for this maiden technique and to do an extensive study with all the facilities in their mines. This is all I've got for today, and thank you very much. Open to the conclave for any questions or discussions.
Thank you, Raghuram. This is a new technology introduced, I think.
Yeah.
And if there are any questions, we can take 1 or 2.
Sorry, sir?
What is the safe distance, sir?
Sir.
Normally, when you undertake blasting, what is the safe distance you can assure for human habitation or roads or other things?
So when it comes to vibration, within 50 to 100 meters, SIMFER scientists have recorded a vibration of 3.5 to 4 millimeter per second.
So up to 100 meters, below 100 meters, we can do.
Absolutely, sir.
Safely.
Absolutely, sir.
Right.
That is the main
And
motto of this.
What in fly rock distance, how much?
So fly rock distance, as you have seen on the video, we have done only with the extreme conditions possible because we have reduced the burden
Okay,
spacing.
okay, with that condition, what is the?
10 meters, sir. 10 to 20 meters is what we observed.
Very good, very good.
Towards the front.
Very
Towards the
good.
front
Thank
face.
you, thank you.
Thank you.
What is the commercial viability to compare to the conventional explosive at present scenario?
Sir, absolutely. Sir, when compared to the conventional explosives, this is going to be more expensive than the commercial explosives we have used because the cheapest option right now is commercial explosives. But this is going to be used only in very sensitive areas where you have
No,
to.
I understand.
Yeah.
Where the fly rock control is required and all, I understand. that.
Yeah, absolutely.
Maybe how many times the commercial, maybe twice or thrice?
So it should be 20% more from what we
20%
studied.
more.
Yeah, 20% more.
Okay, that's fine.
Yes.
One question, actually, see, now the thing is that you have to reduce the carbon footprints, whereas you are adding carbon to the environment. How it justifies?
So here we have reading with Mr. Johnson, my colleague also has. The Simfer scientists have also put in some readings according to the emissions also during the entire test. So if you want to, yeah.
So I will answer this. See, for burning 1 liter of diesel produces 2.68 kg of CO2. 1 liter of diesel burning, just burning the diesel. So for doing blasting with ANFO, for producing 1 ton of limestone, 0.2 kg. 0.2 kg of CO2 produced while using ANFO. For this trial, CPTBT, the yield per rod, yield per hole, 30 tons. That means 0.0001, 0.0001 CO2 produced per ton of limestone. So this is nothing says it will get diluted in the air itself.
One extension question to Narsagaru. How it is better than a ripper mining, where we can use electric hydraulic excavator with the ripper, just like a rock breaker arrangements are there. Recently, we come across such a presentation. So how it is better than that?
Yes,
Any
sir.
comments?
So actually this rock breaker, ripper and all, there is a seismic, we have to do seismic velocity. So with less than 4,000 means we can use this ripper and all. For this, especially for Kallagudi limestone mines, the hardness of the limestone, it's called pink limestone. It does 120, more than 120 MPa, megapascal. So where the ripper is not feasible. That's why we have tried this trial.
We'll take one last question.
This can be reusable?
Yes, sir. Reusable.
Reusable.
As of now, 50 times we can use this
50
same
times.
tube.
That
It is made from C or M142, the tube.
5 meters. 5 meters.
So it's on the trial only. So based on the bench height, we can, increase the length of the tube.
As per the DGMS guideline, flying fragment should not be more than 10 meter, but you are telling that it is more than 20 meter, 10 to 20 meter. You are violating that laws, no?
No, so actually the trial is taken in the worst scenario, sir.
Okay.
So during the trial, the fly rock was maximum, 20 meter.
But as per the DGMS guidelines, it should not be more than 10 meters. Okay.
One last question.
Good morning, sir. I just wanted to ask, like, this technology, can this be used for hard rock mining, like for benches which are around 180 MPa? Like right now, I have some experiences with rock breaking technology such as rippers or rock breakers, and we have seen very high productivity in Tata Steel right now. We are collaborating with many teams. So I just wanted to know, like, how will the fragmentation be in this hard rock mining? I work in an iron ore mine. The hardness there is around 180 to 220 MPa. So how will it work there?
So, very good question. So I'm not sure if you have observed in one of the trial video that we have just played on the AV. So the rock nature that we had it in Dalmiapuram has some cavities. Not in all of the benches, but in some benches they had some cavities and fissures. So the clay intrusions between that has actually pushed it. So if the clay intrusions were not there and the cavities were not there, the breakage mechanism would have been even more better. In one of the trial that we have done here, it was purposely put on those benches which has cavities and which has fissures to see how it absorbs the pressure released by the CO2. But as long as it's completely tight packed and there is no reason that the gas can escape through a fissure or a cavity, it's going to have its 100% efficiency. We're going to tap its 100% efficiency towards the braking.
So it has certain limitations to cavities which are present, so the gas might leak, or areas where the strata is a bit fractured.
No, the Simfer scientists have also given a solution for that. You don't have to drill the hole right through a cavity. That is what we did on purposely, to see how it reacts if we drill the hole right on a cavity. But the solution that they have provided is to shift the drilling hole next to a cavity where it is around 2 to 3 meters away from it. And then it's just going to have the fissures connected to it. And then it's going to push it. So we have solutions for that.
And what is the maximum UCS till, like, you have had experience with this technology?
It's 100 MPa, sir, but when compared to ultimate strength. Yeah.
So in Kallagudi limestone, it was around 200 MPa rock also there.
Okay, sure.
Actually, we have got permission to do trial in Kallagudi limestone only from the DGMs.
Okay, got it, sir. Thank you.
Would this come under the purview of the PESO?
So sorry, can you repeat it again, please?
Would this CPT-BT come under the regulations of PESO, petroleum explosives and safety, or like normal explosives do?
No, sir. We have already got a NOC from PESO, sir. We have already submitted.
And then what other statutory departments would it come under?
Sir, we are under active consideration with DGMS, sir. We have submitted the proposal with DGMS.
No, I mean, whether the Cylinders Act and all these things, whether pressurized cylinders like in other
Yeah.
Would it come under that purview?
Sir, absolutely. SMPV, it comes under SMPV, sir, for the storage of the cylinder and storage of the gas, but not for the technology as such.
Okay, for storage.
For storage, absolutely.
And what about for the filling of the cylinder?
No, sir. Filling of the cylinder, it's not. We are tested. We have the pipe testing certificates and everything, sir. But rest of the technology is lying with the DGMS, sir. It's under their purview to approve this technique for use in the mines.
Okay, once approved, would you conduct trial blasts if required? On payment basis also if required?
Absolutely, sir. It can be done. Okay, sir.
Thank you.
Thank you.
Thank you, Mr. John.
Sir, only last one question, sir. To use this in mines, suppose a large mechanized mines, how we have to go? We have to open something like a workshop or magazine to fill these gases, etc. Or are we having any agencies to ready-made supply the pipes?
Sir, what we have planned and what we have proposed is the entire preparation of the steel pipes, or the entire preparation of the process will take place only outside the mining area, very far away from the lease area. So what will happen just now just like we have the explosive van coming in and out of the mines, we are just going to bring in the pipes inside the mines, and after its usage, we're going to recover the pipe, and just through a transport vehicle, we're going to take it out of the mines. So all the preparation process will be handled by us. It will be taken care outside of the mining lease area.
Okay,
whatever pipes we are putting inside, so it will be recoverable and that will go off.
No, it is recoverable, sir. As Mr. Johnson said, it can be used up to 40 to 50 times, reused.
It will not blast.
No, sir.
Thank you. Thank you very
Thank you, Mr. Raghuram and John.
Thank you, sir.
We will move on to the next speaker. Next speaker is Mr. Srikanth. He will be... Yeah. He will be speaking on field evaluation of stemming plugs in limestone mining, a case study. Mr. Srikanth is a promoter and managing director of Uttam Loss Tech Private Limited, Hyderabad, with over 4 decades of experience in the explosives, mining, and construction industries. He has held senior leadership positions at Salvo Explosives and Chemicals, Premier Explosives, Tamil Nadu Industrial Explosives, and Ideal Industrial Explosives, besides serving as director of Kuram Rock Blasting Company, Muscat, and Tirthankara Infra Limited. He holds an MTech in mining engineering and MBA in finance and an LLB. and he is currently pursuing PhD at NIT Roorkela, a life member of MEAI and International Society of Explosives Explosives Engineers. He has authorized several technical papers on controlled blasting and quarrying. Yeah, Mr. Srikanth.
Good morning. Thank you, sir. Thanks for the great introduction. Good morning, dignitaries on the dais and off the dais. So this is one of the case studies of stemming plugs which we did in Zuari limestone mines, Ramapuram limestone mines of Zuari Cements Limited. See, one of the challenges that mining engineers and construction engineers are facing today as far as blasting is concerned is the cost of explosives is going up. Maybe we can blame Trump for it. So that leaves us with only one option, that we need to reduce the cost. And if you ask me whether is it going to be a temporary affair, let me tell you the bad news, that it is not going to be. Because around 18% of gas production in the world is affected. And it will take at least another 2 to 3 years for it to come back. So another 3 years at least, be prepared to suffer the higher cost of explosives. Even if that is assuming that the Hormuz is open. So that leaves us with only one option, that is save the cost of explosives. And there are only 2-3 ways for doing it. One is blast design optimization, stemming plugs and air decking, and borehole liners. And you would have observed in most of the places, blast designs have been optimized to a great extent. And borehole liners can be used only in particular places where there are cracks and crevices in the hole. And that leaves us with only one option, that is evaluating stemming plugs. So theoretically, this is a well-proven product. It has been there world over for the last 30 years. So the advantages are well-researched. It controls throw, it results in better muck pile, improves the fragmentation, and reduces the flare-off. The working principle is very simple. You create an air deck, and because you are creating an air deck, the compressive wave which is formed when you detonate explosives gets reflected and becomes a tension wave, and most of the rocks are poor in tension compared to compression, so the fragmentation improves and gas expansion happens, and this gas results in better fragmentation. So this is one of the case studies where we tried in Sitapuram mine of Zuari Cements Limited. This is in Suryapet district of Telangana. I'm sorry for this thing. So half the face we drilled, blasted with normally what we used this thing, and in half the face we used stemming plugs. So this is how stemming plugs are used. We created a air deck of around 1 meter. Just put the put stemming plug on the top, insert it through a stemming pole, and that's it. So this is, excuse me. Okay, this is a video. Where part of the face which we used were done with stemming plugs. You can clearly see the difference in fly rock and throw. The side where stemming plugs were used, you can clearly see the lesser throw and better muck pile. As far as cost is concerned, the stemming plug cost around 183 rupees. We found that per hole, we have saved some money. So that has resulted in a saving of, assuming a density of 2.5, that has resulted in a saving of around 1 rupee 47 paisa per cubic meter, and at a density of 2.5 grams per cc, around 0.59 rupees per ton. And accompanied with good throw, good fragmentation. These are the primary readings. See, we have started selling this product, trying only in the last 2-3 months, and we feel that, and research also proves that there is a scope of up to saving of up to 30%. But yeah, this is around 10. The saving here is around 10%. Now I thank the management of Zuari Cements for giving us permission to try this out. Thank you. If you have any questions, I will take now.
Thank you, Mr. Srikanth. So floor is open for questions, if there are any questions. If there are no questions, I think we will move on to the next paper. It is from Mr. Sanjeev Kumar Tiwari. He will speak on smart mining, advancing smart and intelligent mining practices.
Sorry.
Mr. Sanjeev Kumar Tiwari is the General Manager, Technical Services at Deepak Mining Solutions, a wholly owned subsidiary of Deepak Fertilizers and Petrochemicals Corporation Limited. He has done B.Tech in Mining Engineering, graduate from IIT ISM Dhanbad 91 batch. He has over 30 years of mining experience. He spent 12 years with Coal India Limited across various subsidiaries, followed by the 18 years in Canada with leading global mining companies, including Barrick Gold, Newmont, Agnico Eagle, and Argonaut Gold, heading technical services. Since 2024, he has been leading the technical services department at Deepak Mining Solutions, bringing extensive expertise in mine planning, technical operations, and mining excellence. So over to Mr. Sanjeev Kumar.
Thank you, sir, for the introduction. Respected dignitaries on the dais, of the dais, mining experts, industry leaders, ladies and gentlemen, very good morning to all of you. I think we'll start with the presentation very soon. I chose this topic of smart mining because it resonates with the work experience I have overseas. I did the similar work working at the gold mines, where the challenges were fragmentation or dilution or control. And it also resonates with one of the case study I'm going to present before you. My company did it in one of the limestone mine here. We'll share the details shortly. So that's why I chose this topic. It's a very common topic nowadays. People know about smart mining, know about all the technologies, but we'll discuss the challenges of doing it and some of the recommendation at the end of the presentation. But I will just start quickly with the company overview, and we'll go to the case study. So Deepak Mining Solution, I joined this company 2 years ago in 2024. Born last year. The parent company name is Deepak Fertilizer Petrochemicals Limited. As a known company, 40 plus years old, and the uniqueness of this company is we are the only producer of low density ammonium prill in the India, and one of the third large producer of ammonium nitrate. The company has 2 or 3 verticals, main verticals. They produce industrial chemicals, crop nutrition, and technical ammonium nitrate That's a department where it's our department, mining solution comes under that. So if you look at this slide here, it shows the entire integrated value chain a company has to offer. We have a gas tie-up with the Middle East, one of the countries, and by using the gas, bringing the gas, importing the gas, we produce ammonia, we produce nitric acid that converts into ammonium nitrate by a chemical process. We all know that. We also have going to have diverse product, more range of other explosives and some initiating devices very soon. The uniqueness for our company is we are also offering solutions. We believe in hand holding. We just don't supply only product. We want to stand by. We want to join hands, identify the issues a mining company has, and then work together, collaborate with them, and try to resolve the issues, try to share the details, share the technology and the experience with them. And the end goal is definitely production improvement, productivity improvement. So you can see the entire chain here in the top. We all know that any mining is there are two main activities, upstream and the downstream. So upstream activities means main two activities are drilling and blasting. And under downstream, the rest of the activity comes load and haul, crushing, and then beneficiation, other things come after that. So you see the left picture shows about the tools, the technology, the things we do to control these two activities, which is drilling and blasting. We have the expertise and full control on these two activities. The impact of these activities, upstream activities, or on downstream activities is huge. We'll show you in the next slide, just to give you a comparative, the percentage, the cost involved there in the entire value chain. So on this slide, if you see in general, it's 18 to 20% cost is involved in drilling and blasting. If you think about the total cost of mining any commodity, the major cost is the downstream cost, which is almost 80%. You can see the breakup here. It's not the exact numbers, but this shows the range there. In that range, the company or the mine site invest or incur money to produce the product. So that's why it is just shown. You can see if you invest 20% of the total cost in drilling and blasting, the results would be much better. You will be saving more costs downstream. So that's the idea of just showing this slide here. And how do we do that? Can optimize drilling design, can rock specific explosive loading, charging roles can be designed based on that. And by doing other things like the timing and doing some prediction with using some AI tools, we can see the downstream improvement. We can also track that and show you the results. We'll talk about more details in a couple of next slides. Little bit of NFO, it's nothing new. We all know, we are all mining engineers. We understand what is NFO. The benefits are we can produce higher powder factor, can go lower down the cost, can improve the drill yield. Because of the gas energy, can have better fragmentation. Because of the lower density, you can have a better control on the vibration. And because of the lower density too, the charge distribution in the hole is better than any other explosives. That results in better fragmentation. For any blasting, you know that there are two, three variables are very important. The charge distribution, the confinement, and the benchiometry and all the QA/QC work. So it helps if you use the lower density product, because for the same kgs put into the hole, the charge distribution gets better. This is one of the case study I'm going to share with you. Very interesting site. One of the Ultratech cement limestone mine had some issues. The top benches were producing a lot of boulders. At the same time, the bottom benches were overblasted, so producing more fines. So they had all the issues to control because of the overblasting. There was an issue of ore dilution. The ore dilution was causing a lot of time invested in this segregating the ore and was affecting the overall productivity of the mine site. So that was the main issue. So our team got engaged with them, worked with them. We spent some time identifying their practices and then did some trial with their consent. We made some recommendation in changing the design parameters. We use AI-based software and simulated the blasting scenarios by changing the design parameters. And we're able to control the dilution and improve the productivity by 32%. We'll show you in the next slide. So that's what we did there. We improved the powder factor. D&B cost was also optimized. Ore dilution was controlled by doing all the exercise. We call it TCO, total cost of ownership. The concept is about controlling some of the key activities and evaluating the impact of that throughout the value chain. So just pay attention on this slide. This is a very interesting, a very unique geological, deposit. You can see this is a top view here. You can see that there are some intrusions on the either side of the bench. There was a high-grade limestone on the left side. There was a pegmatite intrusion in between, and then there was a low-grade, not low-grade, it's an average-grade limestone. And on the right side, there was another intrusion there. It was a vertical intrusion. So when they were blasting, the ore was getting mixed with the other material due to rock movement, material movement. And the excavator was spending hours to segregate that, then load into the dumpers to save the grade. So by doing simulations, changing design parameters, predicting the movement of the blast, the throw of the blast, we were able to control the material movement, and we're successful in doing the segregation of the material in the blast. So you can see the muck pile was separated during the blast, and that helped to improve the tons per hour of the excavator because they were able to send the excavator right up to the high grade, and material was filled into the dumper in very less time. You can see the dumper fill time also improved, almost 30% of time improvement there, 16% in the productivity improvement there by doing the optimized blast. The idea is to explain that there is a technology, there are things available in the market, in the industry. All we have to do is just give it a try. I know the potential is there in our country, in here. We have the smartest engineer in the world, I can tell you that. But what I found is a little bit of gap in the adoption of digitalization. I think it's happening. The concern only is the pace of that. It's not very. It has a lot of scope to improve that. The Prime Minister's vision of advanced country in 2047 is not too far. So we have to work now. We have to decide how we can go ahead, how we can improve the productivity by adopting the technology. These are just the reports, screenshots of reports we do. We create the burden relief. We can create a heat map on all those things. That helps. So we fly the drone, we get the images, the software teaches them, produces all the DTMs, and that helps us to understand the the actual effective burden in the front row of the blast. And we all know that's the first row, the first hole which blasts decides the goal of the blast, decides the destiny of the blast. So if that fires correctly with the right effective burden, the blast performance will produce desired results. Sorry. Yeah, so it's the same. It's more detailed information about the drill yield improvement, powder factor improvement, rock breaker hours were also reduced by reducing the boulder size. That's another one exercise, a case study. It's a very prestigious one. Navi Mumbai, the new international airport we were also part of that development, and there was a lot of challenge. There was a deadline to achieve the material of spec size because they were using that material to do some construction work at the buildings nearby. And the challenge was there was a limitation of vibration control because there was infrastructure close by up to within 180 meters. The PPV restriction was there to produce not more than 22 milliseconds. Fragmentation to the spec was required, and fly rock was also the concern. So we collaborated with the management, local management there, and worked together, and with all the helps of experience, knowledge, technology, we were able to achieve the results. The PPV was 17.5 millimeters per second at the structure where the point of concern was. Fragmentation was, there was improvement of 12%. DAT material was reduced by 12%. And fly rock was not beyond 70 meters. The structure was away. So this is one of the another study we did there. Now we come to the actual topic. So I did not want to spend much time on this because we all know. It's available on the internet. It's available, everyone knows that. What is smart mining? What are the options there? So I will go quickly through those options and we'll discuss about the challenges we have. So in layman language, smart mining is just an intelligent connection between the physical data which is captured and stored in the field on the equipments, and that can be transferred with the cloud-based technology to the offices, and dashboard can be analyzed using industrial Internet of Things. That's the basic concept, but there's a lot of details. If you want to know more about it, feel free to connect with me. We'll explain you more. Just a little bit of importance. It enhances the safety. I will go through the main points because of the time crunch. I think the safety can be enhanced by use of technology, by using remote drills, automated trucks. Operational efficiency can be improved by using this technology. It's more sustainable. It optimizes the resource uses and emission tracking to meet environmental regulations too at the same time. The specific application to the mine, some of the points, real-time equipment monitoring can be done with the use of IoT sensors. Environmental safety monitoring can be done by detecting gas levels, air quality underground. Ground movement, slope stability is very big. It's a very important point and was a big concern there in hard rock mining because we were blasting to fragment the rock and was shaking the entire slope. So the challenge was not to produce vibration beyond the limit. So all those things can be watched. We use the radar. The live monitoring was done by my team. And we were able to get the trigger before like 20 days in advance before the slope collapse. So we evacuated the area 15 days before when the fall happened. The reason of telling this is the technology is there, options are there, all we have to just embrace it and take decision now. I think sometimes looks very expensive and not feasible, but we'll discuss about those challenges and some of the recommendations later on. Fleet and worker management can be done by using those technologies. IoT-enabled fleet management system is available there. Wearable gadgets are there. The worker can wear it and go to underground. If there is any exceedance of gas emission, they will get the trigger, they will get the alarm, so they can be removed from that area. Mining produces huge data every day. So data management is also a big challenge for any mining industry. But that can also be handled very accurately, very fast with the help of these technologies. Can also predict the maintenance, very important role of equipment, knowing the equipment downtime in advance. So by doing predictive, preventive maintenance, you need to know when is going to need the maintenance. So you can predict the maintenance by just monitoring the behavior of those equipments by installing some of the sensors. And it can directly transfer the stress created on the equipment. So you can watch that, you can simulate the conditions and find out that when it's going to fail, and you can take action. Autonomous haulage system it was happening before, it happened after I left, but it was happening before me when they were trying to use electric autonomous trucks in the field. It was a manless truck, but Barrick was also using underground manless trucks operated from the top in my office. From there, the operator was controlling the movement of autonomous truck underground. Other AI-driven process optimization, intelligent control system optimizes mineral processing parameters. There's another application to mining industry. The NLP streamlines the administrative tasks, like the text messages, the audio messages can be directly converted into actionable items using NLP process. Automated drill rigs, we all know about that, can be used. You can continue drilling in the field without evacuating the people from the areas for the blast. So increases the productivity, you have a better control. You can constantly drill remotely. And in the danger zones, you can also continue drilling. So all those are advantages of using the technology. Safety and efficiency benefits are there. Fleet management, we already talked about that. Robotics are also nowadays getting attention, and people, the companies are trying to use that in the dangerous zone, the inspection for the areas. The robots are going there, taking pictures and coming back and providing the information, can be analyzed on the softwares. So that can be used for the inspection. Aerial drone surveys are very common. We are also doing it, but you can fly drones in the inaccessible areas, get all the images, monitor the dump movement, monitor the wall movement, all those things can be done. Automated sampling, maintenance can also be done by robotics. Robots can be used. Emergency response, remote operated robots can address the emergency situation. If there is a fall happens, we can send the robot and can rescue the worker, can do other things needed. Comprehensive data collection can be done with the help of technology. Operational
Sanjeev Kumar,
efficiency.
another 2 minutes, please.
Sorry, we'll finish soon. Operational efficiency optimization, production efficiency, real-time monitoring and response. Quickly, we go to the challenges. So the big challenge is the high initial capital investment. That is definitely a challenge. But I think if there is an option, I don't know if the government can support that by giving some loans at low interest or zero interest for a couple of years. So the management or the mining industry can use that money and invest it. Because sometimes it's difficult to know the ROI, there is no clarity for the return on investment in the beginning. It will pay off by itself in a couple of years, but it depends how much you want to spend. So, or another option is we can do some trial. You don't have to buy the whole the whole technology, but you can do into parts and see the results to justify the investment and then go for a bigger investment. Limited digital infrastructure is another challenge. We don't have a robust network. I think we have to build that so that all this technology can work. The mindsets are remotely located, so that's one of the challenge. Workforce skill gaps are there. We have to train our people, make them aware of the value and there is a psychological fear of losing job by doing this. But I think we should use it as a tool. Cannot replace human brain. The decision making, it cannot replace that. It can only speed up your processing. You can improve the accuracy. So there is that fear. We have to just overcome that and prepare our people to adopt and use it. Cybersecurity risk, sometimes companies are worried about that, data is going out into the clouds, but they are safe there. There is no issue with that. And we can also ensure that that can be taken care of. Unkilled ROI and value realization, I spoke about that. Operational complexity. The complexity is the way we do things is because of the manual intervention. We can make it easier, better, and more effective by using this technology. The future is the automation and AI use. Fully autonomous operations. The mining companies overseas, they are going for it. Sustainable energy practices will also come with the use of this in future. Advanced data and quantum computing can be also done. Global collaboration and circular economy. Interconnected mining network promotes shared insights and circular economy principles for sustainability. So that's the future outlook of the technology. Just quickly go through some of the innovative solutions we are offering. We have some device which can use the used oil instead of having the diesel to mix with the ammonium nitrate. We can also mix it with the used oil, which is a challenge for any mining company to deal with that. We have done a lot of trials mixing with certain portion like 20, 80%, up to 50%. We have seen good results of the blast. Did not affect the overall performance. So this machine is there are two chambers. Can be the used diesel can be mixed with the fresh diesel, and it's usable to produce that required energy in the NFO. Some of the other things we can provide the AN loaders can help to speed up the loading process into the BMD. Stationary mixer will also help to provide that, and we provide our explosive truck with the account so that the NFO can be directly charged into the holes. That's it about. Thank you very much for your time.
Thank you, Mr. Sanjeev Kumar. If there are any questions, we will take one or two questions.
Hello? Yeah, can hear you. Sorry, sir, I cannot hear you.
Since 2 decades, everybody is reading this IoTs and all these things. Automation, truck dispatching system, or remote sensing system, all these things. The main thing is that When a cell phone, a common man is procuring a cell phone with a 20,000 rupees in a year, a mining entrepreneur cannot able to procure the system which will improve the productivity of the mines since 2 decades, because
Right.
the developers of designers of these IoTs is not in a position to produce their products as per the requirement of the society. That is the prime condition. It was 2 decades back thing everybody is thinking about in the same mining conclave in 1997 or 2010 or so, the automation of truck dispatching system and all these things. And the implementation of the statutory compliance. You see, before 8 years or 9 years, when drone survey has been made statutory implication, nobody has thought of using the accurate mineral assessment at the end of the every year. When it was made statutory requirement, the product developers also come into the front with a liable solution for the end users, so that the thing has come into the picture. Now the thing is that the IoT producers are not in a position to make the mining community, yes, this product can be used by small scale mining also. There is a vast requirement for these things with the implementation of the same, but the same has been not been done by the what you call the designers of this IoT. That is what the end user is required, and end user is focusing towards the same. They are ready for implementation of the same. At least the middle scale industries or large scale industries ready to implement the same for their improvement of productivity. But the producers of the designers, the IoT suppliers were not in a position to make their products as per the requirement of the society. That is what the biggest claim what we are facing, I think so. That's why the paper is been since 2 decades. It wasn't same like that. Auto truck dispatch system or digitalization, everything is there. But what is the end result that we have to request all the IoT producers to make the mining community better aware of these conditions?
Agreed, sir. Great question. I fully agree with you. The challenges are there for sure. The cost is there, and I think the government has to support that, and the regulatory and the other bodies have also do some trials with those system and see the use of that. And the management has to understand the value of this down the road, because you cannot see the benefits tomorrow. Once you invest it today, I think it will take a couple of months, maybe 6 months to see the value there. And I fully agree with you that we have to work as a team and support each other, maybe collaborate with I'm not sure exactly the bigger players, but yeah, definitely all those challenges are there. We can discuss more, and I think the Indian startup companies can take over and do equivalent job. Like if you go for the companies outside the country, I think it's very expensive, but the same IoTs can be prepared here. I think some of the companies are working on it, but they need the acceptance. They need a chance to prove that their value. So for that, probably we all have to do the trials. Unless you try something, you don't get the results. Mining, it's so site specific. The need of any site would be different. So the startup has to prepare the customized solutions for each and every site. And it's doable. It's just about the collaboration and support from each other for everyone.
Thank you, Sanjeev Kumar.
Thank you, sir.
I think I thank all the
Sir,
speakers.
one more question. One more question, sir. Sir, a disaster risk reduction component has been taken care, sir, because you mentioned about startups. Any funding is there from Government of India or this one?
That was my thought, sir, that there should be some support from the government.
I was just thinking, you have any IoT, because this gentleman was mentioning about IoT, right? Risk reduction is there. Any work is done on disaster risk reduction in the mining activities?
Disaster restriction, you said, or?
The disaster risk reduction. It's called risk reduction. Now, the portfolio of disaster management is totally changed when Disaster Management Act 26 has come in, where mining industries, they want to bring down all the disasters happening in the mining industries, loss of life, environmental degradation, pollution, all that. So you should have this DRR component in all the activity what you do at the mining industry. So where that component has been what you call integrated with the operation system with the
Yes.
mining industry, that's
Yes,
what
yes.
is.
It is done, and there are options. See, if you can see, we can start monitoring things. You know the risk coming, then you can take action in advance. So that is the management. Disaster management is part of that. You cannot stop any disaster to happen, but you can take action to minimize the impact. If you know the wall is going to fail, you take the corrective measures in advance, and evacuate your people, can do some wall rehabilitation, things like that. So there is a lot of technologies available in the global industry. I think must be available in India too. It's just about the adoption and going to try it that will help us.
Thank you, Mr. Sanjay Kumar.
Just a
You can
minute.
have discussions or.
Yeah, sure. Feel free to catch up with me if you have any more questions.
One last question,
There is a
please.
technology upgradation fund.
Yes.
You can explore. It is basically for technology upgradation for MSMEs. I think you'll find the details on MSME site of Government of India. Maybe you can think of that.
Okay.
Yes, one small suggestion for the IoT, sir. See, we used to watch cricket from so many years, but earlier in that cricket, the dashboard was not very clear and we were not understanding actually what is the score, what is the percentage required, how many balls remaining. And now when we watch a cricketer, even if you are not watching from the beginning, if you are in the end of the 2 overs also, we understand the entire match. So in the same way, we request you to give a dashboard in such a way that a layman can understand what actually you want to give to the customer.
Absolutely, and you raise a very good point. It's similar way you see the matches on the screen. Same kind of dashboard is prepared by this technology. You just click the button or just go on the page, refresh it. It will give you the live information of all the equipment performance. Graphs will be created. So those are the beauty of those things. You have to just go through the demonstration, look at those options and the features of those technology, and you will appreciate it for sure. It's similar to the match, watching a match.
Thank you. I think I thank all the speakers for excellent presentation. Mr. Y.S. Reddy.
No need to address all of us. Yeah. See now, I'm just sitting quiet because I'm not come prepared to chair a session. It's a sort of completely thrilled to listen to the speakers. Subjects are such that even for youngsters it is something new. Not able to, industry is not prepared anyway. But there are certain things which we have done differently, but same thing is now being can be faster. You can do without thinking, without even reading your brains. You can plan things like that. I was reading other day just to know. I'm giving an incident of how I felt. I'm a very old timer. I passed out mining engineering in 1966. And I worked only in all traditional mining in Goa. Iron ore mining, serving steel industry in Japan. And we had no chance except to do the everyday activities to survival type of thing. And we used to do what we can do with that limited resources or ideas and equipment. But over time, we have learned so many things. When I went to Goa, we were not knowing how to blast, drill, what is the correct size of drill hole, what is the type of explosives, what is the type of what is the type of crushers we can use. That was time in 1968, 69. So over time, necessity is the mother of invention like that. We have continuously learned how to find better solutions and how to do things better than how we were done before. So as I'm listening to speakers today, all that is coming to my mind. Particularly, I give one instance of blasting. Ammonium nitrate we are using. Ammonium nitrate were the main explosives. We learned in Goa, it was just introduced about that time, in 1969, 70s. only we are using as a main explosive ammonium mixed in the site only with diesel and pour into the hole and keep some booster. That means nitrogen explosive, one or two cartridges, and then blast by using delays or directly or whatever it is, what available. And then finally, the whole size was only 115 mm. So blasting was not taking place. It only blasts. It moves ground. It develops cracks in that, and then pushes out. And some of the like that was happening. So what was the solution? We used to think, my colleagues and whatever it is, went on reducing spacing and burden. It means to reduce, improve blasting fragmentation. We were trying to reduce spacing and burden. There was a time for 110, 150, 100 mm borehole, drill hole. There was a time when it reached almost to 2 into 2 or 1.5, 1.5. Finally, it came to 1 meter by 1 meter. In one of the time, I stood on the road and explained to him, what is this going on? I stood on the two boreholes, drill holes, standing, stretching my feet. Then, pardon? Yeah, okay. No, I say, okay, I shorten this one. So we learned that ammonium nitrate was not explosive at the time for a small hole. It has to be, at least hole diameter should be at 200, 300. For that purpose, people are using ammonium nitrate. They're also using large excavators and all that, so it can break afterwards. So that was the time when I discarded ammonium nitrate, used only high explosives of nitroglycerin, which was used as a booster, the main explosive, and increased the hole size to 4 by 5 or 4.5 by 5, and then yield was what was to be 4 into 2, it became 25. So like that, we discarded for years in Goa, ammonium nitrate, because we were always using small explosives, 110. So when I was reading over this one, how ammonium nitrate is not explosives unless it is for a large diameter. Small explosives you cannot do. So this, and still we are using, I also learned, for certain excavator size of the mine, we cannot drill 200 mm, 300 mm boreholes. So it has to be within optimum 100. So I want to share this. What else I could have shared with you? I'm not a researcher. I'm wrongly selected me as chairman for this session. Anyway, no, you saved my flight. Okay.
There is one more presentation. Please bear with us. Mr. Patel and Deepak Sharma, the Naresh Patel, and if they are there, you please come to the dais. They will be speaking on non-blasted mining solutions for sustainable mining. You have 10 minutes. You please try to complete it within the time.
खत्म कर देना यार.
Good morning, everyone. A very warm welcome to all the delegates and dignitaries from DGMS, MSAK, and MEAI to this National Mining Conclave 2026. Today, on behalf of Volvo Group and Volvo Construction Equipment, I would like to thank MSAK and MEAI to be part of the conclave. I am Naresh Patel, and I take care of the product portfolio management for Volvo Construction Equipment in India. And I have with me my colleague Deepak Sharma, who focuses on the attachments and the special application solutions that are required for the construction and mining industry for the country. So we work together to bring new solutions, technologies, and innovative ideas to the mining for India. As all of you know, I think Volvo has been a pioneer in the mining arena in India for the last 25 plus years, We entered India in 1998, 1999 beginning, and from there on, we have been continuously providing the solutions, technology innovations, and of course, I think the most important part of it, which I think many of the speakers have spoken, is to contribute on the high productivity, the fuel efficiency, carbon reduction. These are some of the areas that we work on globally as well as in India. Yeah, so I will just take you through this journey. The topic today we have is talking about sustainable mining and blasted technologies. We have worked on it at a couple of sites in India, and my colleague would be talking further on that. Before that, I would like to take you to the agenda part of it, what we would be covering. The introduction part, I'm running pretty quickly because we have shortage of time here. The kind of products that we offer in India, types of mining, and the challenges that the mining industry faces today in India, the available solutions that we have for the non-blasting solutions, and the working principles behind that, the applications, and what are the customer benefits that come along with these technologies is what we would be speaking more. All along, I think yesterday and today morning, we have heard a lot about safety. So we, as Volvo, are proud to say that safety is in our DNA. I mean, anything that we talk today is all about safety, quality, and committed to leading the change, which is more of environmental care or the innovations that we talk about. So on the screen, what you see is some specialized solutions like the articulated haulers that we offer in India. I think we just spoke about Goa, and that's where I think we have these articulated haulers working where, I mean, the rainy season where anything else cannot work, the Arctic haulers is what keeps the mining business running. Yeah. And the last picture that you see is the autonomous electric solutions in hauling that we have piloted in Sweden. Yeah. So just a small anecdote on the safety part of it here. What you see here is a 3-point safety belt in an automobile. I mean, that's the first step towards safety that the world took. And I'm proud to say Volvo has been the inventor for this 3-point safety belt, which was never patented because it was more to do with the safety of the humanity in general. So it was founded by Mr. Niels Bohlin in 1959. This was a gift from Volvo to the world. Yeah, so we are very proud to tell you this. I think some of the people sitting here are aware, but so I'll just run a video. Yeah, so that was a very small glimpse of the fact that we care about safety when it comes to any construction or mining sites. This is the industrial footprint that we have across the globe. And of course, Bangalore in India is one of them. So we have a production facility here, a large facility for excavators, a facility for Volvo trucks, a facility for Volvo buses where we do that. And then we proud to say that India, Bangalore is one of the key R&D centers also for the Volvo group. And we are expanding soon. We are doubling our capacity in the next 2 to 3 years. Yes, will be fast. This is where we do our manufacturing. Started India operations, as I said, in the later half of the previous century. Yeah. And we also have, we also heard about people talking about operator trainings and things like that. We have invested in a world-class facility, which we call it the Volvo Construction Equipment Customer Center. This facility is in Hoskote in Bangalore again. And we do a lot of trainings. We have invested on simulators here. We have a simulator on wheels, which we take it to the sites. I think that is more of getting a hands-on to the operators and talking more about safety and things like that. Yeah. This is our presence in India. I think we are actively in the country, 18 to 20,000 machines currently working in the country. I'm talking about the machines, not the trucks as of now. We have 21 domestic dealers and as high as 1,100 service and salesmen across the country through our dealerships. And the product lines that we offer in the country today is ranging from excavators to wheel loaders, artic haulers, and road making machinery, including the attachments and the special application solutions that we need to offer on these machines as the base carriers. When it comes to excavators, I think what we offer to the country today is right from 20-ton to the 90-ton excavators, which are used primarily in both construction, heavy infrastructure, or mining applications. When it comes to the wheel loaders part of it, we are there from right from the 4-ton to the 15-ton wheel loaders, be it face loading or be it rehandling of materials, we are there. And probably in the mining segment, when it comes to these range of equipment, we lead in this country. Of course, contractors are our largest buyers, but then we also deal with Coal India subsidiaries, where we have supplied a lot of these equipment.
Another
And
5 minutes.
these are the articulated haulers, right from 25 to 55 tons is what we provide. So probably the next slides, my colleague Deepak would be taking you and briefing you on the technology that we talk about here.
Yeah, good morning, everyone, once again. So I will not taking much of time. So my friends have already explained type of mining in the previous presentations. So it's conventional and sustainable mining, blasting and non-blasting. So for non-blasting, currently, if you see the challenge, so the customer challenges, if you see blasting restrictions, then safety risks and vibrations, and then noise complaints, environmental challenges, and then mining, which is closer to the habitat or some national highways, as explained by my friends. So the solution, if you see the current solutions available in the market is a breaker, vibro ripper, and the one which we have worked out is a BRMC 85. So that's the brand which we are taking it forward. So coming to the working principle of all these three different solutions which we are offering. So I will not go through the text which is explaining. So I will just run the video. If you see the sound of the breaker is something which you can hear, but the vibro ripper sound is hardly you can hear. So it is working like 50 decibels or less. So it is again, you can operate in areas like near to the office or some other areas, or in the housing complexes also. So apart from the mining. Now, suggested applications for this solution, because we have multiple solutions. How you can select like which attachment or which solution is applicable for you. So based on the RQI, it's a rock quality index. So it can be easily selected like which attachment is good for you, for your site. So now if you see the combination, the BRMC 85, actually it's a combination of a vibro ripper and a specially designed arm, which gives roughly 56% higher ripping force as compared to the standard ripper. So what we have done, we have fixed a 85-ton class of vibro ripper in a 50-ton class of excavator, which is giving us a lot of advantage. It is working in one of the iron ore mines in the eastern part of India. So we'll talk about in the coming slide. So how it is creating the value for customers. So like it's creating it's high frequency vibration fracture rock, then no explosive are required. And then it's a continuous operation. No need to stop the mining operations. It's a continuous operation, like currently where it is working in continuous shifts. So for customer, it is safe operations near urban and sensitive zones. It's a low noise and minimal ground vibration. It's a minimal effect on the mineral quality. That is also ensured with this solution. And then on the fuel consumption, as I mentioned, we have developed this attachment for a 50-ton class of excavator. So we are able to save a lot of fuel when it compared to 85-ton class of excavators. And then which is resulting further in its low cost per ton. Just to update you on the site where it is working in Tata Steel Joda East iron ore mines. So it has crossed around 1,800 hours, and it is very well appreciated by Tata Steel and as well as the other contractors who have visited this site. So some of the data which I will talk about on the productivity, it is giving 200 to 250 TPH, and then with the fuel consumption of 27 to 29 liters per hour. So that's the site data we have. It works to be somewhere around 60-65 rupees per ton from the customer perspective. So that's it from our side, sir. So if any questions.
Thank you, Team Volvo.
And sorry, we run very fast because.
No, only one question. We are running out of time. Yeah, no, you are still always speaking.
Hello, sir. Is it only workable in the secondary blasting, or even primary can also be done without
Sir,
blasting?
Sir, it is for basically for primary breaking, blasting, sir. Primary breaking. Yeah, it's not for
avoiding
secondary.
the primary blasting.
Yes, sir. Yes, sir.
So, what will be the cost of that attachment? What you are shown?
Sir, actually, including the excavator attachment, it will be like 4.25 CR.
4.25 CR.
Yeah.
So, can it has been tested in the limestone mining?
Sir, actually, we have tested in iron ore. Iron ore happens to be, I will say, slightly harder material. So limestone, we are exploring actually if we get an opportunity, like one of you can work, maybe we can work together.
Sir, we can give you permission for demo. Can you make an arrangement for demo?
We can definitely, sir, we can definitely work.
So limestone and dolomite both, if you can arrange a demo, this one. So there are hundreds of mine owners who can ready to buy this.
Right.
No, they will be happy to give demo. Please move on to the next question.
Sir, my small question is,
Yeah.
are you manufacturing any electrical machineries for underground mining? I don't think you are manufacturing electrically operated machinery, because for underground we need only electrical machineries.
Yeah.
Okay, you know the answer also, then we will move on to the. Yeah, no, take so. Wait.
No, but a small correction, sir. We have articulated haulers which can be converted to low-profile dump trucks, and we now have electrical machinery available there. We have electrical excavators, a 50-ton grade electric excavator, which we have already got in India, in Bangalore itself. I mean, if you have the time, we invite you to visit our facility today, tomorrow, whenever it is convenient to you.
This BRMC breakers, what class of excavators can you attach it to?
Sir, 50 ton.
50 ton, not
50
below that.
Not below that, sir.
And what's the weight compared to the normal? What's the weight difference compared to the normal breaker? And if this is heavier, do we need to increase the counterweight size?
Yes, sir. Sir, we need to carry out some modification in terms of counterweight as well as in hydraulics also to make the excavator suitable to run 85-ton class of ripper.
Thank you, Volvo team.
Thank you, sir.
And thank you all the speakers. I thank the organizers for giving me an opportunity. Thank you. Over to organizers.
Now I request Chairman Shri Y.S. Reddy to hand over the mementos. Shri Johnson, Assistant General Manager, Dalmia Cement Bharat Limited. And Shri Shrikant Vaidakare, Manager, Director, Utham Blastech Private Limited. Now I request Shri Co-Chairman Dr. T.N. Venugopal to hand over the mementos. Shri Naresh Patel, Head of Product Management. And Shri Sanjeev Kumar Tiwari, General Manager, Technical Services. To hand over the mementos, Shri Raghuram. Now I request Sri Narasimha Murthy sir to hand over the momentous to Chairman Y.S. Reddy. And co-chairman Dr. T.N. Venugopal. Thank you, sir. High tea has been arranged outside the hall. Please take a break and come back soon. Within 15 minutes. Please come back soon.
And we have one more good news to announce that we have to check your luck. We have organized Lucky Dip. All you have to do is take out your Lucky Dip coupon from your seminar box and write down all the details and keep one copy with yourself and drop another copy in the Lucky Dip coupon box, which has already been kept in all three dining areas. And the lucky draw will be done during the concluding session. Kindly drop your lucky coupon in the box and check your luck, please.
Thank you.
ಇದಾದ್ಮೇಲೆ 2 ಸರ್, ಮಧ್ಯಾಹ್ನ ಊಟ ಆದ್ಮೇಲೆ.
Now I request to all assemble the hall. Welcome back everyone. Now we will begin technical section 5. Topic on securing critical minerals for an Atmanirbhar Bharat. Now I request technical section chairman Shri Krishnendu Mondal, Director of Mine Safety, Mining, Ballari Region 1 and co-chairman Shri G. Narasimha Rao, Director of Mine Safety, Electrical, Southern Zone, Bengaluru. On the stage please sir. Soumya. Thank you, sir. Handing over to you, sir.
This session, session 5, I am requesting to come the dais, Dr. K. Jayashankar, for the topic, Advanced Beneficiation and Extraction Technologies for Titanium and Rare Earth Minerals, Dr. K. Jayashankar. Sri Iqbal Basha GM, second speaker, Radiological Surveillance, a unique technique in uranium for precise demarcation of mineralized zone for mining recovery of mineral reserves. Sri Iqbal Basha GM, second speaker. Third speaker for this session, Srimati Danish Sunko, for the topic, a digital measurement, reporting and verification framework for compliance and decarbonization in critical mineral supply chains for battery energy storage systems. Okay, thank you. For these stations, every speaker shall have 20 minutes each. And question and answer session shall be taken after completion this session. Okay. Without wasting time, I am requesting Dr. K. Jayashankar for the topic. Please, Dr. K. Jayashankar. Dr. K. Jayashankar is scientist F in the critical minerals and metal divisions at CISR NIIST, Trivandrum, with over 23 years of experience in metallurgical research and industry. He holds a PhD in metallurgical and materials engineering from IIT Kharagpur. His expertise includes the extraction and value addition of critical minerals, rare earth elements, titanium, graphene, and precious metals using sustainable processing technologies. He has published 50 plus SCI indexed papers, holds 5 Indian patents, and is a recipient of the CSIR Raman Research Fellowship in the year 2024 and the IEI Young Engineers Award in the year 2015. His current research focuses on industrial scale technologies for titanium oxide production, graphene manufacturing, and recovery of precious metals from electronic waste. With this introduction, I am again requesting Dr. K. Jaishankar to present his paper.
Thank you, sir. Thank you, Chairman and Co-Chairman, for nice introduction. And before going to the present, I'd like to thank the organizing committee for the wonderful opportunity to present such a important the conclave, which is happening the National Mining Conclave in Bengaluru, and is a very important topic now. The country's growth all depends on the mining and minerals. It plays the important role of our country's GDP. And when look into the mining safety, which there is a lot of talk was going on for yesterday and today. So my talk is a little bit different, but I also little bit more concerned about this safety of this, not during mining, particularly the after mining and beneficiation and storing the rejects and slimes waste in the mining area. So that is also very serious concern of all the mining industries, because already we know that some of the overburden tailings which you stored in the pond or in the different regions, after some time it accumulate and it creates also major accident. It happens in many places. We just found that. And what I'm just going to give some, as a researcher, we have been working for this beneficiation and value addition extraction from various minerals. I have some case studies which really helpful for whatever they were mine waste or mine rejects, which is generated in the mining. And now most of the waste or slimes, which is also having the lot of rare metals and critical metals, now that is the more value than the major source of your area. Already I have introduced about my research topic. I just give a brief what we are doing at our institute, especially the critical minerals and metals. And as you know, the Kerala and the Tamil Nadu the seashore, we have a lot of beaches and minerals where it contains the titanium and rare earth. So we have worked on the titanium beneficiation as well as the extraction from the ilmenite mineral as well as the rare earth material. In the rare earth concern, actually, even though if you beneficiate or extract in the form of rare earth oxide, the purification and the metal form is a very important end product. So that is one of the unique expertise we have. And most of the battery materials or ceramics which we are working in as a recycled materials. The critical metals which now it is used for many of our EV as well as our semiconductor, where the huge demand is going on. But all these metals and materials require the purification. Without purification, you cannot use it for any of these applications. So we have the facilities for that. So just I'll touch upon the mineral sands, but it is also similar to the mining places where you can find different types of sand. As you know, the beach where you can see the black sand, it is called as contains the ilmenite and zircon, and as well as the rare earth minerals are present. Even in terry sand also it has there, and most of these minerals, titanium based minerals are there. But the issue is all these minerals here, when you want to extract the titanium oxide, so there is other impurities also present. You have to remove those type of impurities by the advanced beneficiation technique. And I just want to give you some in-depth understanding of, if you look into any type of the minerals or mineralogical structure, if you see, the region-wise it is different from based on this moisture and atmospheric contents, especially if you look into the iron oxide, the FeO, Fe2O3, these are it is not as a impurity, but this has to be separated separately, then only you will get as a titanium oxide. And as you know, FeO is very difficult to separate it out from the beach sand. So we have developed the unique process approach how to remove this FeO and Fe2O3. This is the overall flow sheet. Actually, now the beneficiation, where we can say the physical beneficiation, usually it goes as a flotation or a cyclone separator or gravity separator. So now whatever the slimes or tailings or where the concentrations are very less. So there is another type of, you have to go for chemical beneficiation or thermal beneficiation also it coming. It's not that you are going for the complete using of chemicals or like a pyro or hydro type of processing, but there will be a little bit of your, that is a read of the temperature as well as the mild chemicals are required to enrich and this rare earth minerals as well as the titanium. So I'll just give you some of the things why this type of enrichment, what we have done different from the industry, especially any type of extraction, the iron removal, the simplest way is you can use any acids, the iron can be taken out as iron chloride, iron sulfate. But we have not gone that one. So we have used as another process as accelerated rusting, where we reduce the acid consumption 77%. Because this is the one of the important aspect when the industry is processing, they should not having any generation of other acid waste from the thing. So we can avoid producing the acid waste by this type of process approach. And for that, what we are doing it, I just want to give how the science and mechanism plays. If you look, the Fe2O3 is a mineral as a one compound. When we have the controlled heat treatment or controlled thermal treatment, where the titanium oxide will remain as the core and iron gets off the surface. So this way, where you can, wherever your tailings has nickel, chromium, or manganese or vanadium, you can control your roasting conditions and bring this, when if it is associated with iron, you can make it separately coming on the surface. So you can easily separate out by this approach. We have another process. This is a very simplest aeration rusting. There is no acid, only the water has been consumed. So what I just want to show, when you look into this image, how this iron is get separated. So you can see with the help of this aeration and applying these aeration conditions, it gets easily separated. The iron will be separated in the iron oxide precipitate form, and titanium will settle down. So in this process, there is no acid is involved. There is a mild thermal treatment. Even you can make a enriched of 85% of titanium oxide, you can enrich. You can see the starting material, which is titanium is 62, 63, you can get at 85, and especially the iron will be very less amount of iron is present. It can be easily go for any hydrometallurgical process. And there is another process also we developed. It is a smelting process. So the slag, actually, especially the steel plant industries, there is a slags are being produced. Even the slag is also having some of the important rare earth materials, metals and presence. So you can beneficiate like this type of approach where you can produce the individual rare earth oxides. So this process actually, which the lab scale, which we made, and this is also demonstrated in the pilot scale, even industrial scale, we have tested the conditions. This is the one way of where you can enrich the material, required material, the titanium or any other nickel or chromium, manganese from lower grade to you can enrich the higher grade of the material without much acid usage here. And I just want to show another example, red mud. We all know the alumina industry is one of the major problem of handling this red mud. As we have been hearing the red mud, we have a good quality of bauxite, so we are the largest producer of alumina. The main problem is the handling of the red mud. At present, these red muds are stored in the pond, in the near the plant, the mining premises. Even you can look the 1 ton of alumina, there is a 1.5 tons of red mud is generated. And particularly in our country, we have a huge accumulation of red mud. Because this is the one example where you can think of any of the sludges or dust fines is generated in the same thing. It can also applicable the process which we develop for the red mud. The another problem is the red mud having the highly caustic in nature. So it has a alkali, so very difficult to process, handle that, the red mud. So as I said, so when the mining safety, there is a lot of incidents also happen when it is the stockpiling of this type of tailings or sludges in different way. So there is a pond accidents happen in many places, which I just Brazil and China, Hungary and all. And so because we are the second world largest producer from the aluminum production for red mud, but there is no holistic approach. So what we looked into so we have to, the red mud is basically, it is a iron is more, means which is there. But what we looked into this, so we can recover whatever the metals or material presence in the red mud. So the metals which we found in the red mud, it's not only iron, there is a good amount of titanium and also the good amount of rare earth metals also present. So titanium why the titanium is important, even though if it is concentration is low, so you can see that titanium is still our consumption is huge. So in whatever way the titanium is produced or enriched, it has a good market value and it has many applications and market. And another important is a rare earth. So in modern industry, you know that rare earth are being used in many of these applications. So most of the rare earths we are being imported, especially these magnets, EV vehicles and catalysts we are using in the red mud. And these rare earths are really very costly, even costlier than some of the rare metals is costlier than your gold or the precious metals. Because of that reason, because we have the rare earth presence in the with lower concentration, many of these slime sludges. But why it is expensive? Because this demand is more and supply restriction and difficult to process and produce these rare earth metals. So I'm just giving the glimpses. Every year the consumption and requirement is going up. Yeah, what we did it here again, the red mud. This is a sludge, titanium plant sludge also. We produce the ferrotitanium alloy because these sludges contain some of the sulfur is present. So that the industry is not able to use these sludges. So we converted into the useful product of ferrotitanium alloy. And these are the conditions we used. The red mud actually, which what we did it, we initially taking out the iron, which is the maximum content presence in the red mud, and we use this slag. This slag as the titanium and rare earth are enriched in the red mud slag. So why we used this process? Because most of the rare earth is associated with the iron. So when you use any type of beneficiation, magnetic separation or hydrometallurgical process, the rare earths will travel into the iron only. So that's why initially we smelted, we removed the iron in the metal form. So most of the rare earths are concentrated in the slag and iron is required. Then from this slag, so we also process to get the alumina. So this also one way you can, whatever the alumina presence in the red mud, it can be extracted and easily. So these are some of the reaction and conditions we follow. And the red mud, where I said the rare earth presence in the red mud, which is simple, you can do the mild acid leaching and filtration, you can enrich this rare earth precipitate. But one of the important rare earth metal presence in the red mud is the scandium. The only source available in the world, scandium in the form of in the red mud, in the bauxite sources, and which is available in the red mud only. Why the scandium is important? Because it is used in many of these magnets as well as the fuel cells, the advanced EV that is requirement. But the cost, if you look into the scandium, even the 1 gram of scandium metal, it costs is 50,000 rupees. Even we cannot compare with the gold also. So that's a high value metals are present in this type of industrial waste. And we also develop another process where you can enrich the titanium oxide for titanium extraction. And another important, as I said, it is not only the enrichment or extraction, you have to, another step you have to go in the product level. The one way we made it in the aluminum scandium alloy, which is where the defense, they usually use this type of material for their applications, improving the strength of the aluminum alloy. So these are some of the process we optimize and produce this alloy. And the next step, what we did, as I said, the metal from ore, we are enriched, beneficiated the scandium in the form of scandium oxide. From scandium oxide to metal, we converted. As I said, This is the very high value of the material compared to any other metals presently in the market. Even the scandium oxide per kg, it costs almost more than 1.5 lakhs, but the scandium metal still, the 1 gram itself, it cost is 40 to 50,000 rupees. So this we demonstrate in the lab level. Just I want to, what I briefed here, this is the same methodology. It can be used for the slimes as well as the sludges, any type of mining waste, where if you have any nickel also can be concentrated and extracted by this approach, as well as the chrome tailings. Even we have found a lot of the low grade that chrome tailings are rejects also there. You can enrich and beneficiate by this type of simple approach. And similarly, you can use the vanadium or any other metals presence in the sludges and wastes. It can be enriched and separated by this method. And just giving another expertise, because what I found, some of the steel industries also presence here. As you know, the carbon capture is one of the important topic. So already a lot of industries, they are working on that. And in our institute, we have the one pilot test facility. As you can see, the blast furnace having the different types of stowaways, gas composition. So nowadays, a lot of material development is going on. Very difficult to test these gas compositions required for the blast furnace. So what we did, we made one reactor in our institute. So this is the pilot bed test facility. Any type of gaseous absorption or reduction or reducibility, it can be tested with the large amount of your sample can be tested. So this is the first time in India we created this facility. So as he said, you can have a different reducing conditions. You can study the different types of
5 minutes left.
Yes, sir. I have 1 or 2 slides. So this is the one unique facility available. So who are interested in anyone interested for using and understanding the real gaseous environment which is generated in your plant, it's the same. You can we can develop this mixing of the gases and test the test bed is there. You can test all the conditions using this mixture of these gases. And these are the different types of reactor vessels we have. And we have some controlled unit furnace. This is actually required some of the pyrolysis of your, suppose if there are any sludges or anything, if having a sulfur or phosphorus or any other acidic contents. So we use and we try to distillate and condensate it, those type of sulfur by using this facility. And this is one important facility. It may not be immediately understanding, but now the fly ash or any other the industry waste, suppose if critical metals are in the form of very ppm level,